This is your video lesson for Learning Targets 1 and 2 of our first unit. Your first two learning targets focus on the content found in the Glencoe textbook 1-6. You do have the option to read and take notes, but this is your second option of listening to the examples and taking notes on the examples that I will read and do on my iPad for you, okay? You'll notice at the top of your notes there are spots for vocab words. Please make sure you are filling in the definitions on these vocab words. You'll probably notice that the spacing's a little bit different on mine. That's just for iPad purposes, okay? So no matter what, you definitely need to read the textbook to obtain the vocabulary words definitions, okay? All right, let's first look at example 1, where we're solving an and inequality, okay? We are solving the inequality 13 is less than 2x plus 7, which is less than or equal to 17. We're told to graph the solution set on a number line. Your textbook gives you two methods of approaching this inequality. Personally, I'm all for method number 1 because I think that method number 2 lends itself to getting lost in your work. So I'm going to proceed with method number 1, where I break my and inequality into two separate inequalities. Notice that my first inequality contains what's on the left-hand side as well as what's contained on the middle part of my inequality. The 13 is less than 2x plus 7. I'm separating my two inequalities by the word and. My other inequality also contains the middle component of our inequality as well as the right-hand side of our inequality where 2x plus 7 is less than or equal to 17. For both of these inequalities, I'm going to first subtract 7 from both sides. So I'm kind of solving both of them at once, but again, I'm showing all my work. So now we have 6 is less than 2x, and 2x is less than or equal to 10, okay? Over here, I'm going to divide by 2, and over here, I'm going to divide by 2. Make sure we're remembering if we divide by a negative number, we must flip the sign. We did not divide by a negative number here, so it's not of concern to us, okay? Oops. I'm going to use my eraser because I divided by the 2. All right, so then over here we have x is less than or equal to 5. So our final solution set reads 3 is less than x and x is less than or equal to 5, okay? I like to read these things out loud and just think about them logically, okay? It is possible for x to be bigger than the number 3 as well as less than the number 5, but we could also equal. So I'm first going to create an open circle at the 3 because it's not or equal to. I'm then going to create a closed circle at the 5. The content that lies in my solution set will lie between these two values. That's why it creates an and inequality. Notice that throughout your notes there are spots called study tips as well as other blank spots for notes. This is definitely where you're going to need to open up the textbook and write in some thoughts, okay? I specifically only put the study tips if I felt that it was a necessary piece of content that you guys may need. Alright, we're now looking at example 2 where we're solving an or compound inequality. Ors are naturally separated for us, so now we can just separate them ourselves on our paper and solve them each individually. We're also asked to graph the solution set. Y minus 2 is greater than negative 3, or y plus 4 is less than or equal to negative 3. For my first inequality, I'm just going to add 2 to both sides, giving me that y is now greater than negative 1. Or, over here, we're going to subtract 4 from both sides, and we get y is less than or equal to negative 7. If we're looking at this logically, y is greater than negative 1 or y is less than or equal to negative 7, it makes logical sense because both cannot happen at the same time, which is why it's going to be an or inequality. So once again, when I go to graph this, I'm going to plot a spot at negative 7, give him a closed circle because we're or equal to, and plot a spot at negative 1, give him an open circle because we're not or equal to. Y is greater than negative 1, that means we're going to shade to the right, and y is less than or equal to negative 7, we're going to shade to the left. Okay? All right, now we're looking into example 3 where we're starting to solve absolute value inequalities. The first one we're going to take a look at is when it's a less than. We're solving for the absolute value of a when it is less than 4. A little handy way of remembering this to me, which actually is not in your textbook, is less than, can be pronounced as less than. Okay? Less than absolute value inequalities actually create an and inequality because there's actually two possibilities that are true. I like to separate this into the fact that A is less than 4 because I can plug in values that are less than 4 and I'm still going to get an absolute value that is less than 4. Example, I can plug in 3. The absolute value of 3 is less than 4. The other scenario I need to worry about, two things must happen. I'm going to flip the sign and I'm going to negate the other side. The A values must be greater than -4 because if I start to go beyond -4 into -5, my statement is no longer true. This has to be separated by an and inequality because values must lie between 4 and -4. So when I go to graph these on the number line, I have a -4 and I have a +4. They both get open circles because we're not or equal to, and we shade between the values. All right, we're moving right along here. We're now at example 4. Just like I had a little way of remembering the less than, I also have a way of remembering absolute value inequalities that involve greater. I like to call these guys greater because all greater absolute value inequalities will create an or compound inequality, okay? The absolute value of A is greater than 4. Well, obviously we can have values where A is greater than 4. For example, if I plug in 5, the absolute value of 5 is indeed bigger than 4. Logically, the other spot that this can happen is when A is going to be less than -4, where once again, notice that I'm having two things change. First, the sign flips, and second, we change the sign on the right-hand side, or whatever our value is, okay? So now, when we go to graph him, once again, I'm going to plot two spots, -4, +4. Both are going to get open circles because we're not or equal to, and then I'm going to shade. Now in this one, A is greater than 4, so I'm going to shade to the right where I'm bigger than 4. And I'm less than -4, so I'm going to shade to the left. Okay? Notice again, there's a study tip for you to fill in. Now we're looking at example 5 where there's actually multiple steps to solving absolute value inequalities. Sometimes there may even be more steps than the one I have shown here. I want you to notice what we have isolated. You first should always have the absolute value inequality isolated. So if there was something being added or subtracted outside of it, I would want you to move it to the other side, okay? So I'm now going to create my two separate cases. 3x minus 12. First, nothing happens. Nothing changes. I'm still going to leave him greater than or equal to 6. Greater, as I just said before, means or. It's going to create an or compound inequality. The other inequality it's going to produce is 3x minus 12 is less than or equal to -6. Okay? So notice once again, I changed only the sign and the inequality itself on this second situation. Notice I didn't bring the absolute value bars down. That's shown by creating my two separate scenarios here. I'm now going to solve both of these separately. All right, so notice that actually the steps are going to be the same for both of these problems. I'm first going to add 12 in both scenarios to both sides. Okay, showing all my work here. So we have 3x is greater than or equal to 18. Now over here we have 3x is less than or equal to 6. Now in both of these I'm going to divide by 3. So we get x is bigger than or equal to 6. That's a terrible 6. I need to erase that, that's for sure. 6. And then over here we get x is less than or equal to 2. Okay? When we're reading this statement out loud, x is greater than or equal to 6, s is less than or equal to 2. We are or because we can't be both bigger than 6 and less than 2 at the same time logically. Love those logic statements. All right, so when we go to graph it, I'm going to plot at 2, I'm going to plot at 6. The 2 and the 6 are both going to get closed circles because I'm an or equal to. So now, or That means we shade in the opposite directions. Where I'm less than or equal to 2, I shade to the left. Where I'm greater than or equal to 6, I shade to the right, and you've solved an absolute value inequality with multiple steps. All right, the last example for this section, it has to do with real-world problems. These are typically the sticking point for many students, so don't worry if you don't understand it at first, okay? So let's actually read this problem out loud. To prepare for a job interview, Megan researches the position's requirements and pay. She discovers that the average starting salary for the position is $38,500. But her actual starting salary could differ from that average by about as much as $2,450. We're told to write an absolute value inequality for the situation as well as to solve the situation, okay? Well, let's take a different approach. Maybe that'll help you understand what the textbook is saying. If we're saying that our middle value that we're starting at is $38,500 that she could make. Okay, oopsies, too many zeros. There we go, that's better. But it could differ as much as about $2,450. That means I could be more than $2,450 or I could be less than $2,450. But no matter what, I am between these two values, okay? So, something that you should recognize. This just created an and inequality. And the amount or the distance away from our middle value is our $2,450, okay? So that's why we're going to create an absolute value inequality. In this quantity here, he's in less than because it's creating an and inequality, must be within $2,450 of something, okay? So now we need to figure out what's going to go on the inside here, okay? Well, difference means subtraction. If you didn't notice that word, here it is right here, differ. Difference means subtraction. So we can have this total amount of $38,500, and we're going to take away X, where X is just going to represent Megan's starting salary here. And now we have enough information to solve our inequality. But hopefully this little visualization up here in my corner has helped you see what the solution set actually is. Okay, so you can always work backwards if that helps you, okay? So we're going to have $38,500 in the middle, and we're going to go up by $2,450 and down by $2,450, okay? So that's why when we create our two separate cases, we have 38,500 minus X is less than or equal to 2,450, okay? And we're also going to have 38,500 minus X is greater than or equal to negative 2,450, okay? I'm actually going to leave the rest for you to solve on this problem, and if you're still a little bit lost, make sure you're looking at the textbook.